I have two big problems to tackle: the oscillations at lower current levels, and a new power supply to isolate the fan power from the rest of the voltage rails. So I started looking closely at the 45 kHz oscillation I was having, thinking it was related to the DAC update rate of 45 kHz. After a bit of digging, I just didn't see how my digital control was causing the oscillations. It was puzzling to me. So I did a test. I did away with the digital feedback for the current control. I set up a mode to take the value I set with the input knob and just send that straight to the DAC register, clamping the value so it doesn't go below or above the limits for the DAC. This is the voltage at the load input terminals. This kinda answers my question as to the power supply switching noise causing a problem. This is at about a 300 milliamp load, but that sine wave must be caused by the power supply switching transients. Here I'm at a little over 700 milliamps. It's just getting to the level where it wants to start to oscillate. It's also quite evident that the switching noise from the power supply is causing a ringing in the MOSFET power circuit. By 1.2 amps, it's all over the place, and close to 5 volts in amplitude. As we'll see in a bit, it takes a bit of current to impose that on the output of a 600 watt linear power supply. And it's not just one frequency. There are a lot of different frequencies mixed in that waveform. A lot of bad stuff going on there. Now some current waveforms. Here's the current from my makeshift current sensor. Output is about 100 millivolts per amp. Can see the MOSFET turning on way too much, close to 6 amps for the tall thin spikes. That's a 6 amp spike when the average current should be in the 1 to 1.5 amp range. If I drive it a little harder, it becomes this: a more even oscillation around that 45 kHz range, and peak current is probably a little over 11 amps. That's just not good. Drive it a little harder and the oscillations stop. Well, still have a bit of stuff in between the switching spikes, but I think that might be being triggered by the power supply switching noise. At about a 3 amp load here, and about 1 amp of it is ripple at a pretty high frequency, not counting the switching transients, not what I want. Here at a 10 amp load, it's pretty flat other than the power supply noise spike getting into the mix. Fix my power supply and that would work okay. So I have a serious design problem with my MOSFET power modules. They are not going to work at, say, less than 4 amps, well, about 2 amps a module. Not taking into account the op-amp swing from the negative power rail was a huge oversight on my part. I believe that is where most of this problem comes from, but maybe not all. I think most of the problem stems from this section here. There is no negative supply for this amp, so when the output of the amp is supposed to be below, say, 60 millivolts, under about 2 amps flowing, I don't think it's a very linear output. This amp may not be good enough either. Any gate drive resistor below about 150 ohms starts to cause ringing in the output. Taking it to the extreme of a 0 ohm gate resistor, it does reduce the range of the horrible oscillations from about 740 milliamps to a little over 1 amp. Here, at a 1.2 amp load, the large oscillations have stopped. But there is all kind of ringing, and the ringing stays all the way up the current range, actually increasing in amplitude a bit as the current goes up. So I think I'm hitting the limit of how fast I can drive this MOSFET with this driver, and it's faster than I need if I can stop the oscillations. As I found it to be a fool's errand trying to filter inside the feedback loop, I'm going to have to try and isolate where some of the different problems are coming from. The reason I put this amp here like this was to try and eliminate the effects of stray inductance from the current feedback. This terminal here has short wires that go back to what is right now the common ground. From there it goes to the main current shunt, through the main current shunt, to the negative voltage source of whatever is being loaded. More wires, more inductance. This may be a good idea just horribly implemented, or maybe it's just a bad idea. But I've got to see if this is where my horrendous current spikes are coming from when under 3 amps of loading. So I'm going to make some modifications. I'm going to do away with this section, eliminating the near ground output from the op-amp. Of course, the gate threshold on the MOSFET is a little over 4 volts. The voltage drop across a 1 milliohm current shunt, plus the little bit in the wiring, is a very small voltage, which makes the gain of this amp pretty high, right around 470 or so. I'll make this resistor divider to scale the DAC output to close to something that should work. A few extra part pads does make this much easier. Don't even have to lift the U1 leads from the PC board, which is good. These OPA 2189s seem to still be out of stock, so I sure don't want to destroy it. The hot air station just makes changing these SMD parts so easy. Use a bit of old wire wrap wire to jump the current sense to the input resistor. I'll check and see if I have the values close enough to work, and if so, do the same thing to the second module. Here is the AC coupled voltage at the load input terminals at a 1 amp load. Compared to the 1 amp non-modified MOSFET module, a lot of difference. One thing that stands out very prominently in this waveform now is the fan noise, which is why I'm going to have to isolate the fan supply from the other supplies. Can even faintly see the 120 Hz voltage ramp from the power supply. If I zoom in on the waveform here, it's not a multi-frequency amalgamated mess. While it does vary in amplitude, it's all one frequency, 125 kHz, the power supply switching frequency. Here at 2 amps, a small increase in the 125 kHz oscillation, but have doubled the load, and certainly a lot better than the 8 to 10 volt 45 kHz mix from before the modifications. Here is where it is not only not better, it's actually worse, at the 10 amp load setting. Again, the 125 kHz is not increasing that much compared to the load increase, but I've got to stop that oscillation. I think this test has shown me that this part of the circuit is a problem, so for sure there will be a new MOSFET power module. Could the fix be as simple as supplying a negative voltage rail to the op amps? Or do I need to see if there's a way to completely do away with the current feedback in the circuit? Let the only current control come from the microprocessor processing the ADC value from the main current shunt. I think the no feedback approach would require me learning a lot more about the gate threshold characteristics of the MOSFETs, and maybe I should do that anyway. Questions. I am again thinking about working on the power supply next. I was not going to touch it till I got the power amplifier section working, but the fact the problems I'm seeing in the output seem to be related to power supply weaknesses makes me think I should. Here's the switching waveform on a terminal of the power supply transformer. I'm going to leave the vertical cursors the same distance apart for these next waveforms. Here is the AC coupled voltage at the input terminals of the load set at 2 amps. The fans are not running and I have a resistor load on the 12 volt rail, so the power supply is about as stable as it gets. Expanded can see the MOSFET amplifier is oscillating at the same frequency as the power supply switching frequency. Now if I take a look at the current at the load input, again at 100 millivolts per amp. Not sure where the small, maybe 1.5 kHz ripple is coming from. That could be from my digital control. It is in the constant current mode. Expanded can see have about half an amp of ripple at the power supply switching frequency. The isolation of the fan power from the amplifier rails is going to require a new power supply. That I don't see as a very big problem. What I do see as a problem, I'm not sure how the 125 kHz switching frequency is getting into the amplifier section. I do have power filtering on each of the MOSFET modules, so this is the 12 volt supply the MOSFET amplifier sees. There may be the tiniest bit there. I can't see that being the root of the problem. And this is the input signal to the MOSFET modules. Again, maybe the tiniest bit there, just hard to tell. But currently, the way it's hooked up, a 5 millivolt change at the input will be a 100 milliamp change on the load. So it won't take much getting into the input to cause a problem, but I think I would see it. And then there is the possibility that the wires from the power supply are radiating so much of the switching noise that it's just being picked up everywhere, maybe even the grounds. I'm really leaning toward making a new power supply as the first step. Any ideas as to what would be the best direction to head in first, or how to isolate the switching noise would surely be appreciated. Thank you for watching.